Welcome to Chapter 6, Section 1 podcast on Newton's second law of motion, force and acceleration. And the one thing, if you can remember one little thing from this chapter, there's one little equation you need to remember. So the big idea for this chapter talks about when an object will accelerate, and that occurs when you have a force acting on it. So let's talk about that. Acceleration again. Once again, it's a change of velocity divided by the time interval. And we remember that the cause of the acceleration is force. So the main idea of the first section is unbalanced forces acting on an object cause the object to accelerate. So we have any object and it's at rest, and there's no net force on it. The puck the object is in equilibrium. But if we hit that thing, we apply an unbalanced force to it, it's going to change its motion. It's going to accelerate. And if we apply another force on it, we can slow it down again. So we can change its motion again. So when you put all the forces together on an object, that's called the net force on the object. The acceleration on an object depends on that net force. To increase the acceleration, you increase the amount of net force on it, meaning the more force, the more it's going to accelerate. And it's directly proportional to the net force acting on it. So to start developing our equation, we know that acceleration is directly proportional to the net force. So what causes an object to accelerate? Unbalanced forces acting on an object cause the object to accelerate. Section 2. Here's the main idea of Section 2. For constant force, an increase in the mass will result in a decrease in the acceleration. So if we push on an empty shopping cart, you're going to have no problems pushing at all. Push on a heavy one, and it's not going to accelerate as much. If you push on it with the equally hard, meaning with the same amount of force. So the acceleration depends on the mass that you're pushing. So if you apply the same force to twice as much mass, it's going to result in only half the acceleration. Or you could say that if you apply twice as much force to the same mass, it's going to be twice as much acceleration. So in this case, acceleration is inversely proportional to the mass. And we write that like this. When we say something is inversely proportional, we say it's 1 over the mass. So inversely means that if the two values change in opposite directions, meaning if one goes up, the other one is going to go down by the same factor. So we say the acceleration produced depends on the mass that is being produced. Has an increase in mass affect acceleration? For constant force, an increase in mass will result in a decrease in the acceleration.